Good day, my dear learner. You are welcome again. And I thank you for watching my video. But I beg of you to subscribe to this channel for me. You can also like and share my videos. You have never made a mistake at all choosing to watch videos from this channel. Today, I would like us to look at plane geometry 2, that's circle theorems, and under that we are going to consider the topic base angles of angles subtended by a chord at the center of a circle. Base angles. Look at the diagram, beautiful diagram you see on your screen. The base angles are A, E, D and A, D, E. So base angles of angles subtended by a chord at the center of the circle and this is the angle at the center, and it is subtended by the chord ED. So that's all the subtopic is about. We are going to look at how we can find any of these base angles when there is an angle that's subtended at the center by the chord. When you look at this diagram, you may think that all these interior angles of the triangle drawn are equal. So, take your pen and paper. I am going to move angle AED and place them on the remaining angles, and you choose which of them may be equal. Now, look at it. Yes, you can see that angle AED doesn't fit equally on angle EAD. That's why you see the blue color here, which is part of angle EAD. So let me move it again to the last angle and let's see what happens. Good. You see that for angle ADE, angle AED fits equally on it, which tells you that these two angles, that's the base angles, are equal, but they are never equal to the angle at the center. Let me move the chord and let us see what would happen. Now, here is where I have placed the chord ED. I am going to move angle AED and place it on them. But looking at the diagram, you could clearly say that angle AED may never fit equally on angle EAD. That is obvious. But what of the last one? So let's move it and let us see. yes, we can see that it covers about 1/4 of angle EAD. So that is not equal. Let's move it to the last one. Good. It fits equally. This tells us that wherever the chord is moved to, the angles at the base will be equal, but they may never be equal to the angle at the center of the circle. So let's see what the theorem states. The theorem or the property states that angles subtended by a chord at the center of a circle have equal base. So it means that the bases are equal. The triangle formed is called isosceles triangle. For isosceles triangle, two of the lengths are equal, but one of them may not be equal to the rest, and hence the angles at the base are also equal. For this, we mathematically state that angle AED is equal to angle ADE, meaning that when angle AED is, say, 50 degrees, then you need nobody to tell you that angle ADE is also 50 degrees. So let's look at this. Good. What you see here are values of the angles AED and ADE. You can see clearly that they are all equal. So whilst I move the chord, look at it well. When I move it, the angles change and they are all equal. They are giving us the same values. I hope you fix your eyes on that. So these are telling us the values of the base angles, and we can see that wherever I move the chord to, they all give us the same measures. So if you really understand this, then let us move on and solve questions for you to understand this very well. Question 1. Find the value of x degrees if A is the center of the circle. I hope you can do this on your own. So you could pause the video and do it. This is very simple. Let us look at solution 1. If you remember the theory or the property, it says that the base angles are equal when an angle subtend a chord at the center of the circle. So knowing that the base angles are equal, if one of them is 35 and the other is s degrees. It tells you that s degrees is equal to 35 degrees by observation. And you are done. Very simple. I hope you are laughing because you had the answer correct. Let's look at solution 2, which I wouldn't advise that you go through that process when the question is like this. What we may do is that we know that the sum of interior angles of a triangle add up to 180 degrees. So we have to add all the 3 angles and equate it to 180 degrees. So we have 110 degrees plus 35 degrees plus s degrees all equals 180 degrees. Now when you add 110 degrees and 35 degrees, you get 145 degrees plus s degrees equal to 180 degrees. We are looking for x, so we have to group like terms, which means that this 145 degrees should not be here, but rather it should be at the right hand side. And that is done not by magic. You have to add that additive inverse of 145 degrees to both sides of the equation, so that we get 145 degrees minus 145 degrees plus s degrees equals 180 degrees minus 145 degrees. So 145 degrees minus 145 degrees would be 0. And 180 degrees minus 145 degrees would also give us 35 degrees. So s degrees is therefore 35 degrees, and we are done. I hope you are smiling because it's very simple. Now let us look at our second question. If A is the center of the circle below, find the value of A, x. We are going to look for the s value here. B, angle ABC. You can also try this question without looking at the video, and when you are done, you compare your answer. So let's see the solution. From the property, we know that angle ABC is equal to angle ACB. And for ACB, the angle was given as s plus 12 all degrees. So it means angle ABC is also bracket open s plus 12 all degrees. Now, what we must do is to add all these values and equate it to 180 degrees, because the sum of interior angles of a triangle equals 180 degrees. So s plus 12 all degrees would be 2, as angle ABC is also bracket open s plus 12 all degrees. That's why it is multiplied by 2, because the base angles are 2. That's 75 degrees equal to 180 degrees, because the sum of interior angles of a triangle is equal to 180 degrees. Now you have to expand. 2 times s is 2x, 2 times 12 is 24, plus 75 equal to 180. When we add 75 and 24, we get 99. 2x is alone here, then equal to 180. Now we have to group like terms by subtracting 99 from each side, or adding the additive inverse of 99 to both sides, so that the 99 here would be 0 and it will be gone. So we have 2x plus 99 minus 99 equal to 180 minus 99, so that we have 2x, this would be 0, 99 minus 99 would be 0, 180 minus 99 would give us 81. Then we divide through by 2 because we need the value of x, not the value of 2x. So we divide through by 2, as you see on your screen. 2 would go into 2, 1, so it will be left with x. 81 divided by 2, then we get x equals 40.5. And that is what the question is demanding for. So let's look at how to solve the B part, which is angle ABC. Angle ABC is equal to a bracket open s plus 12 bracket close all degrees. But we know that s is 40.5, so we have to substitute 40.5 into s plus 12, so that wherever we see s, we put in 40.5. So angle ABC is equal to bracket open 40.5 plus 12 bracket close all degrees, so that after adding we get angle ABC to be 52.5 degrees, and then we are done. Let us move on to check for our assignment. Assignment 1. Find the value of s degrees if A is the center of the circle. So you see this, these two angles are s degrees, and we have 99 degrees here. So pause the video, do it on your own, and compare your answer with mine, rather than waiting for me to display my answer before you start working. So the answer is s degrees equals 41 degrees. Well done if you had this answer. Let us look at our second assignment. Find the value of y degrees if angle ACB is equal to y degrees. Angle ABC is equal to 11y minus 550 degrees. And A is the center of the circle. The hint is that you should find the angle here. That is BAC. You should know its angle. And when you are done, add all the angles and equate it to 180 degrees and see if you wouldn't get the answer. So the answer is y degrees equals 55 degrees. My dear learner, thank you for watching my videos. Please subscribe to my video, and I will thank you for that. I bid you goodbye until we meet again on this platform. May God be with you all.